Okay, this is columns with initial deflection. So let's look at this simply supported beam. It has already initial deflection y sub 0, and the total deflection is denoted as y. Okay, so when this P is applied, the moment becomes m is equal to P times this y. However, the change in the curvature between these two become change in curvature will be, well, we have this y prime prime minus this initial y prime prime. So we can use the beam equation. So we have an expression for the moment, so we can use the second order or the weak form of the beam equation, which is EI y prime prime minus y naught prime prime plus py. This is equal to 0. Approximation of this deflection we can use, so approximation of the deflection is, well, we see that y naught is equal to, well, a sine pi x over L. So if you remember from the Ritz method, we used a similar approximation. Okay. The second derivative of this becomes minus a pi over L squared sine pi x over L. This is for the initial deflection. For the bigger curve, we can use a similar approximation. And use that y is equal to, instead of a, we can use b sine pi x over L. And again, this becomes minus b pi over L squared sine pi x over L. We can insert this into the governing equation. Insert these into governing equation. So we get EI minus b pi over L squared sine pi x over L plus a pi over L squared sine pi x over L. It's a plus because it's y minus y naught. And double derivative, of course. Plus bp times y, which is just b sine pi x over L. This is 0. We can factor out sine pi x over L. So factor out sine pi x over L. And we can also divide by this. Divide by sine pi x over L. Sine pi x over L. Then what we are left with is EI minus pi over L squared plus A is B plus A pi over L squared plus P times P. This is equal to 0. We can solve with respect to B, and we get that P minus EI pi over L squared plus EI A pi over L squared is equal to 0. Solving for B, we get that B is equal to minus EI A pi over L squared over P minus EI pi over L squared. Okay, so B is equal to A times this minus pi squared EI over P L squared pi squared EI. If we divide everything in this fraction by minus L squared, we get that B is equal to A times minus pi squared EI over minus L squared divided by P L squared over minus L squared minus pi squared EI over minus L squared. And we get that A times pi squared EI over L squared divided by minus P plus pi squared EI over L squared. If we use the fact that pi squared EI over L squared is equal to P sub E, it looks like the critical force. Then we can say that B is equal to A times P sub E over P sub E minus P. So our y of x becomes B sine pi x over L. That's equal to A times P sub E over P sub E minus P sine pi x over L. Okay. If we now take y minus y naught, that is equal to A PE over PE minus P sine pi x over L minus A sine pi x over L. We get that A times PE over PE minus P minus 1. All this times sine pi x over L. So we have that PE minus PE minus P all over PE minus P. That's equal to P over PE minus P. So this difference of y minus y naught, that's equal to A times P over PE minus P sine pi x over L. What is the maximum change in this deflection? In the deflection. So let's call the maximum deflection as delta. This is equal to y of L over 2 minus y naught at L over 2. This is equal to A P over PE minus P sine pi L over 2L. So the deflection is equal to A times P over PE minus P sine of pi over 2. And that's 1, so we get A P over PE minus P. So the deflection, maximum deflection, is equal to A times P over PE minus P. Okay, that's it.